All right, we're just going to review some of the indefinite integrals. We've looked at just basic integrals, and anytime you got a constant, you remember you can pull that constant out in front of the integral and then evaluate. If you got more than one function, you can break it up if needed. Any of those indefinite ones too, remember we're always, once we've done the indefinite integral that we want to put that there's plus a constant on there. We know how to reverse power rule. We've done that one before. E to the x is e to the x. We have all our trig antiderivatives, and remember they're just opposite. So like derivative of sine is cosine, so antiderivative of cosine then ends up being sine. We'll get into these inverse trig ones here in a little bit. And then also this one can sometimes be tricky. 1 over x, you got to remember that's the derivative of natural log. And so antiderivative of 1 over x is absolute value of natural log of x. And then we had our exponential ones. If you're doing the derivative of an exponential, like a to the x, that the derivative is same exponential times natural log of a, and so the antiderivative would be divided by natural log, so that you're doing the opposite. Let's look at one of those. They want us to integrate 4 to the x, and so the if we were to do the derivative of that, it'd be 4 to the x times natural log of 4. So if we want to go the opposite way, and end up with just 4 over x. We don't want this natural log 4 here, so then it has to be over it. So it'd be 4 to the x over natural log 4. Plus there could be some constant here as well. So now if you were to reverse it and do derivative of this, we should just end up with 4 over x. Derivative of constant, that'd be 0. Derivative of this other term would be 4 to the x natural log 4, and then it's still over natural log 4, so then those would cancel out and we'd be left with what we started here. So that's how you handle any of those exponentials. Let's look at some other ones here. They want us to integrate this function. So if you are integrating this, we want to figure out what this antiderivative is. It's tough when you got division. So what you want to look for is there ways to simplify what we have here first, because trying to undo like looks like this was maybe some quotient rule would be very difficult to try and figure out. So anytime you got a monomial term here, which we got in the denominator, we could think of this as all these terms in the top over x to the 6. And so once you split these up, now let's simplify, then find our integral, and it should be much easier here. This first one, there's not really any simplifying we can do, but let's write it as 5x to the negative 6 for finding our derivative. This next one, we can cancel out some of these exponents, and then I'm going to write this one as 4x to the negative 3rd, since we have 3 left in the bottom. This next one, the x to the 6 is just canceled, so it's just plus 2. Now let's find our antiderivative, and much easier here. So antiderivative, the first one, remember you go up a power here. So x to the negative 5 would be adding 1. And then we put the reciprocal out front. So the reciprocal of that would be negative 1/5. We already have that 5 there. And so if you multiply those two together, those 5s would just cancel. So it looks like it's just going to end up being a negative 1 out in front. And you can check it by if we did the derivative of that right now, would we end up with 5x to the negative 6? Yep. All right, same thing with the next one now. Add a power, add 1 to that exponent, so it'd be negative 2. We want to end up with a negative 4 there, so it looks like it has to be a plus 2 out in front. So then if we drop that negative 2 down, negative 2 times 2 is negative 4. The next one is x, kind of like a x to the 0 power here in essence. So if we go up from that one, it'd be x to the 1st power with that. And then So we'd end up with 2x, and then there could be some constant term on here, so then you want to put plus c, and that would be our antiderivative for that one. All right, let's have you try one similar here. Pause the video, see if you can figure this one out. All right, let's see what you got. So we want to integrate this one. I'm going to write this as u to the 1/2. Hopefully you did too. And then what we want to do is separate these and simplify in order to find our antiderivative here. So remember, when you got exponents, you're subtracting. So this would be u squared plus 1/2 minus 2 would be x to the negative 1 1/2, or that'd be negative 3/2. Now let's find our antiderivative. So go up a power would be 3. Reciprocal in front would be 1/3. On our other one, if we add 1 to negative 3/2, it would be negative 1/2. Reciprocal of that would be negative 2. And we want to times that to the 3, so it'd be minus 6. And then plus some possible constant here. So that would be the answer. Don't be surprised if, like, on exam, you might see that also written as this, u3/3, just making that into a fraction. If we'd make the next one into a fraction, it'd be like minus 6 over u to the positive 1/2, which is the same as square root of u. So don't be surprised if you would see the answer written like that as well.